Okay, so right now we're going to work at another type of word problem that's kind of related to speed problems that we did earlier this semester. So I'm going to call these work rate problems because again we're going to look at rate, but this time we're going to look at rate and how, in comparison to how two people work together. So let's have an example. Say you have Robert and Zoltan are painting a room. It would take Robert 5 hours to paint the room by himself and Zoltan 4 hours to do it by himself. How long does it take them if they work together? So we're going to start off the same way. We want to know how long it's going to take them if they were going to work together. So I'm going to call that my variable, because again, it's what I want to know, so it's my unknown. And I'm going to say time it takes them to work together is X. So I kind of already know my operation. If they're going to work together, that probably means I'm going to be adding things to get them working together. So I'm probably going to be adding Robert and Zoltan to get them working together. Now, if I just add the hours, that's not going to make much sense. 5 hours plus 4 hours would give me 9 hours, so it would make no sense for it to take longer if they're working together than if they were working by themselves. So I can't really look at the hours. What I am going to look at is the rates. So I have two people, Zoltan and Robert. And Zoltan takes 4 hours, which we already knew. Robert takes 5 hours. But I'm going to look at the rates, and the reason I'm going to do this is, well, say we have a room. I'm going to draw a 4-sided room over here. Say Zoltan is over here painting this wall, and Robert is over here painting this wall. Their speed shouldn't change if Robert leaves or if Robert stays. Zoltan is going to be painting this wall at the same speed no matter what Robert does. So while their rates doesn't change, the hours that they work should change. So since the rates are pretty consistent, we're going to go with that. So, kind of like with speed, speed is always per hour, and you're always doing the distance per hour, so how much you actually do in an hour. We're going to see how much Zoltan actually does in 1 hour. So if it takes him 4 hours to paint a whole room, then that means he's going to paint one wall per hour. Hopefully that is pretty easy to see. Which means he's going to have 1/4 of it done per hour. So in 1 hour, he'll have 1/4 done. 2 hours, he'd have painted 2 walls, so 2/4, so a half done. 3 hours, 3 walls, so 3/4, and 4 hours, 4 walls. So I'll have the whole thing done. Robert takes him 5 hours, so he paints a little bit less than a whole wall. So he'll have 1/5 per hour. In 1 hour, he'll have 1/5 of it done, so maybe to there. 2 hours, you'd have maybe to here. 3 hours, here. 4 hours, we'll say there. 5 hours, you should have the whole thing done. So in 1 hour, he'd have 1/5 of it done. Okay, so hopefully you see a pattern. It tends to just be 1 over the amount of hours total. So let's see, together, we don't know how many hours it takes them together. It could be 2. Maybe it only takes them 2 hours that they're working together. In which case, in 1 hour, they'd have half of it done. Maybe it takes them 3 hours. They'd have 1/3 of it done in 1 hour. So we're going to say 1 over X. Now again, we already knew the operation. Zoltan, 1 over 4, the rate that he works, plus Robert, the rate that Robert works, should equal the rate that they work together. Okay, we're going to solve these like we solved the rational equations in the last video. So I'm going to go ahead, find a common denominator, and multiply both sides by that common denominator. So let's see, between 4 and 5, my common denominator would be 20. I have to get this x involved, so I'm going to say 20x. Multiply both sides by that 20x. Of course, again, it means I'm going to distribute it to every term and see what happens. Let's see, 20x times 1 over 4. My 4 and my 20 should cancel out to 5. So 5x. 20x times 1 over 5. My 20 and my 5 should cancel out to 4. So 4x. And 1 over x times 20x. My x and my x should cancel, so equals 20. So I have 5x plus 4x equals 20. Or 9x equals 20. Or x equals 20 over 9. I do want to make sure this makes some sort of rational sense, so 20 over 9 is just about 2. A little over 2, but just about 2. And that would make sense. If they're working together, it should be faster than both of them working by themselves. So that's it. That would be my answer. Okay, let's look at another one, see if we can set this one up. Say we have Deanna and Ray are building a fence. Deanna's done this before, and it took her 20 hours. Together, they get it done in 12 hours. How long would it have taken Ray if she was working alone or had worked alone? Okay, so this time we're looking for how long it took Ray by herself. So I'm going to write that down, Ray, and time, because we're looking for a time, and I'm going to call that something. I'll call it X. Okay, I got Deanna. We know how long it took her. It took her 20 hours because she built a fence before. Okay, and they're building another one together. Together it took them 12 hours. So again, I can't compare the time, but I can compare the rate. So let's see, the rate of Ray should be 1 over X. Rate of Deanna should be 1 over 20. Rate together should be 1 over 12. Operation is already there because they're working together. So 1 over 12 is together. So I'm going to say Ray 1 over X plus Deanna 1 over 20 should give me that 1 over 12. Find a common denominator. 12 and 20, my common denominator. Let's see, 20 won't work, 40 won't work, 60. And X needs to be there, since X is in the denominator also. So distribute to make sure everything is multiplied by that 60X. And see what happens. So my first fraction, 60X times 1 over X, my X's will cancel. I'll be left with 60. Second fraction, 20 into 60 will go 3 times, so 3X. Third fraction, 12 into 60 5 times, so 5X. So let's see, 2X equals 60, X equals 30. That's about it. Okay, let's try last one. Meenal and Ben are staining a deck. Ben has a sprayer, so is working 4 times as fast as Meenal. It takes him 3 hours to finish. How fast were each of them working? So this time we're not looking for time, we're looking for the rate. Okay, so let's see what happens. Hey, since we're looking for the rate, I'm going to set up a little bit differently. So, not really much differently. I'm still going to have a Meenal, a Ben, and a together. So time and rate. I just like this little chart. It just makes it easier for me to see sometimes. But time together is 3, so the rate together is 1/3. That was the given, so that was pretty easy. I'm looking for how fast each of them are working. So I'm saying, okay, well, do I know anything about the time of each of them? Let's see, Ben has a sprayer and so is working 4 times as fast as Meenal. So his rate, he's working 4 times as fast as Meenal. It's not taking him 4 times as long, so we're not looking at time again. We're saying he's working 4 times as fast. So if Meenal is working at a rate of X, Ben is working at a rate of 4 times that, 4X. So I can skip the time part here. I don't really need to know that. I already know a little bit about the rate. You can just say X plus 4X equals 1 over 3. Okay, 5X equals 1 over 3, so X equals 1 over 15. So the rate that Meenal is working is 1 over 15. She's going to get one part of it done every 15 hours. Wrong way. She's going to get 1/15 done every 1 hour. Sorry about that. Okay, so then Ben is going to be working 4X, so 4 times that, so 4 over 15. Okay, so he'll get 4/15 done every 1 hour. So hopefully that made kind of sense. Good luck.